Here's the bottom of the MPX 95 multiplex module. And remember how this is a module that plugs into this chassis? In this module, there is one electrolytic capacitor. And it looks like this right here. This is the original one that comes in it. See this little orange capacitor? It's rated at 1 microfarad at 350 volts. Okay? It is almost always bad. Replace it with, just replace it. And that's the one where I put this one in here. I didn't have an axial lead one. I only had a radial lead, so I put that in there, but it's fine. Replace it with either 350 or 400 volt 1 microfarad electrolytic, or if you can fit a film cap in there, or you have one, you could put that in as well, and it would actually be probably be a little better even. But anyway, we are now at a point where we're going to have to adjust the multiplex, because if you recall, that was the only thing in this entire tuner that had problems. So we're going to go through and we're going to align that now. Okay, we are now on this multiplex decoder unit. And the first thing we want to do is, if you remember from the last video, or from earlier in this video, I'm sorry, we saw that number one, there was some strange looking waveforms, you know, in the output, and that we were not getting good stereo separation, if any at all. Now, the first rule of circuitry is, thou shalt always measure thine power supplies. So that's what we're going to do first. And I'll let you know where I am with this, because that's what I did. And I'll open this up a little. And the first thing I'm going to do is check the plate supplies. You have two supplies coming into this module. You have a 125 volt and a plus 160 volt. And of course your heater pins. And these are going to be a little bit high because the line voltage. What I found is this amplifier really likes about 115 volts for the incoming line. And at 119 to 120, everything runs high, as you can imagine. Now what I did do was, if you look down here in the corner, I added a CL60 thermistor. I usually frown on using these because they produce a lot of heat, and they also can be kind of a current limiting device for dynamic power. So I normally would never use this in a solid state amplifier, but in some of these vacuum tube amps, they actually are kind of advantageous. This gives you just about 2 to 3 volt drop on the input, which is still going to give us a little bit high power supply, a little bit higher than the schematic, but it'll at least be safe. So anyway, with that in mind, these are going to be a little bit high, but they should be roughly this. And you can see this first plate supply should be about 95 volts, and then this one should be about 40 volts. And then over here, they're higher voltage. These ones are 160 volts. And then this last audio output, which I think has nothing to do with the problem, are 94. But we just want to see where our voltages are. So right now, I have this connected to the 40 volt supply. And spoiler alert, this 75 volt one I've already tested, and it's a little bit high. It's probably around 80 something. And again, that doesn't surprise me. So let's bring this meter in here and let's turn this on and we'll see what it does. Now see how high that is? It's supposed to be 40 volts, isn't it? But wait until everything warms up. You have to wait for the tube to warm up. And see, it drops down really well. And it actually gets down towards that 40 volts. It's around 55, but then look, all of a sudden it goes right back up. And it's high. And it'll keep creeping up a little bit. And it'll go all over the place. And after leaving it settle for a while, we're about 60 volts. And by the way, I have the FM multiplex turned off. In other words, this thing's powered, but I don't want to have the influence of the tuner or anything in there right now. Okay, so let's take this off. And let's turn the power off. I'm going to let this bleed down a little bit, and we're going to do some static checks. Okay, we're now looking, as I bang the camera around, we're now looking at pin 7, which is the control grid of this tube element. It should be roughly 0 volts. You shouldn't see any kind of voltage. And you can look, it's sitting at about negative 0.7. And I don't think that's right. I don't think that's what we should have there, but then again, maybe we should. Now looking at this schematic again, we have this diode. You have this coil, which is going to block any current from flowing through here because of the high frequency. This is your 19 kilohertz right here. And this should not, basically you have a 1 mega ohm resistor in parallel, or I mean in series with a 10 mega ohm resistor up to this plate, which should kind of, or to this grid, which should keep that down, especially with this 1 nanofarad capacitor here. So I don't think we should be seeing that. So the first thing I want to do is I want to measure all of this. I'm just going to measure some resistances, and I'm going to unplug the amplifier. It's been turned off and everything. We're going to move to resistance testing. And if I check from here to ground, you can see I'm getting 10 megs, and I should be getting roughly 11 mega ohms. See right here? So let's move back and go on this branch right here. And you can see I'm getting 8K. And what I'm looking at right now is this with respect to ground. And it's reading 8K, and it should read 1 mega ohm. Now if this were leaking, okay, this coil acts pretty much as a short to ground when there's no high frequency on it. So we may be reading something through here. So what I want to do is I want to lift this diode to take it out and see if we have our 1 meg in there. So let me get this heated up. And I'll put this in. All right, we got that out, and look what happens. We're now at 1 meg. So now let's go back to our voltage and go back on that grid there. Let's plug this in and turn it on and see what's happening now. Let's see if we get our 0.78 volts there. Okay, it's different, but it's still going up there. Let's see what our plate voltage is like. This is hard around the camera. And look at that. Now it's at 45 where it's supposed to be. All right, let me get a jumper here. And let me connect this diode back up. So here's one end. Okay, here we go. Boom. Look at that. So that diode's bad. It's leaking. And the reason I went through this, I pretty much had a suspicion this was the problem, but I wanted to go through with you and kind of show you the symptoms of what these do. This is notorious. for doing this. These diodes leak. These are germanium point contact diodes, and there are 10 of them in this circuit. So looking here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all the same diode type. They're these point contact germaniums, and it wouldn't surprise me if every one of them has that issue. Now, let me turn the power back off. And I just want to kind of show you something that we have a luxury here today that we can that we can do. Okay, as it so happens, I actually have another one of these MPX 65 multiplex modules. Now this is a newer version. The older version used 12AT7 tubes. This one uses 12AX7s. The later models of these had that, and the reason they did that was, remember, 12AX7s weren't collectible, expensive, tubes back then. They were very popular and common, and by using these, this amp already uses 12AX7s. A 12AT7 is not used anywhere else in these amps, so that was just another tube that they had to stock. So by going to this, of course these aren't ideal for that circuit, but it was reworked to do that. So this is a drop-in replacement. I could literally just drop this in there and it would work, but we don't need to. We're going to fix the one that's in there. I'm going to save this for another project. But if you notice, they still have the germanium diodes, but they used a different type in this one. And if we go to resistance, even with the diode connected, remember this was 7K with that diode in circuit and 1 meg with it out, because you're reading across this 1 mega ohm resistor right here. So let me connect this up, and you can see it's 1 meg, or 990K. And that's what it should be. And you can see with this one still disconnected, it's also 1 meg. And if I just take a jumper here and connect it again, you'll see that's going to go down to the 7K. If I can connect this around the camera there. And see what happens, 7.8K. So this diode's bad. And the funny thing is, if I just read the diode itself, which is what we were doing, you see that 7K. If I go to these other diodes in the circuit in the same manner, like this one over here, this is just the other one, you can see it still reads funny. I'm not getting a really good connection. Hold on. But these are all 10 of them. There you go, 5.4K. And if we go to this one, let's see, where's that diode in that one? It's hiding in here. See, here's the 8. They actually neatened it up on this. But that other one, where is it? They moved it. Give me a second. And of course in this one, the reason I couldn't find it is that diode has been replaced by a 1 meg resistor. So they took the diode out. This, again, they reworked this circuit. There are changes that they made to it. There's a second coil here that's not on this one. They moved it into they moved it into a different location. So some things have been moved around and changed and improved. And the 2 bridges that are used for the 38 kilohertz doubler circuit, they're really neatly mounted on these 2 little bridge boards now, whereas on this one, if you look closely, and I'll move the camera up, you could see they're just kind of hanging out there in midair. See, they're just floating around, but they're all reading not good. You can see, and that's the capacitance in the diodes in that direction, why that makes your meter jump like that. You see 7.3K, they're all doing that. The funny thing is, if you read this in diode mode, it'll read a pretty normal forward drop, 0.24 volts. And if you read the other way around, it doesn't, it reads blocking, so it seems like it's okay. Okay, the phone is ringing today. I feel like the Wonder Pets.
The phone is ringing.
There's another Easter egg for you all to figure out. Anyway, I'm going to replace these diodes before I do anything else. And what I'm going to use is, and these may be the wrong thing for this job, but I'm going to use these Russian point contact germanium diodes. Now, I have several of these on order and they take a long time to come in. But these are the ones I have in stock, and you could probably also use a 1N5711 Schottky diode. Unfortunately, I'm fresh out of those. The only Schottkys I have really don't have the forward voltage drop and everything that I want. So I think these are going to be a better fit. They are not a real high voltage maximum forward voltage, which is, or reverse voltage, I'm sorry. I think these ones are 30 volts or something like that. However, you know, these are similar to a 1N34A, which I think they're maybe 60 volts. I would have to look it up. But I think in the positions that they're being used, I don't think there's going to be any problem with voltage. So I think it'll be safe to use them. If they don't work, we can always swap them out with a different one when I get some other ones in. So let's get that done, and then we're going to go through and test this once again and see if everything looks good. Now that looks better already. The diodes are replaced, and now let's connect our meter and see if that corrects all of our problems with our voltages. So the first one I'm going to go to is that one that was problematic. And remember, this is going to read a little bit high because our mains voltage is a little high. So let's move this over here. Let's turn this on. And let me back this out a little bit so you can see it. And just what we want. Should go down to about 45 to 47 volts, I would say. And it is. Okay. And according to this, pin 1 should be 95 volts, so it's probably be closer to 100 or so. So pin 1, that's the same as this lead right here. And it's 100 volts. Excellent. Okay, now if we go to this lower tube, this next one in line here, we need 160 volts on both pins 1 and pin 6, the two anodes. And that's going to be our frequency doubling circuit right there. So here's one pin. And look at that, 167, so it's 7 volts high. They're all a wee little bit high. And how about this one? Same thing. So that side's good. And really the audio output I'm not too worried about because we were getting audio out of that anyway. So I'm thinking that one's probably going to be okay. And we can always come back and revisit that. I'm more concerned about everything prior to this bridge here. Very good. Now, after doing a brief test on the stereo separation, we're still having some problems adjusting that. And what it turns out to be is this resistor, or this potentiometer, is bad. And you can see it is the stereo separation pot. So you can see right there. It's a 50K pot. And I noticed that the wiper on it is very loose to begin with, which really doesn't surprise me, but I don't think it is making any contact or good contact with the wiper, the shaft versus the wiper. So let's move this over where you can see it a little bit, and I'll kind of show you how this works. So going across the two terminals of the pot, you can see we're right about halfway. It's a 50K pot, and it's right about at 25K. And if I rotate it, I can't get my fingers in there as it is, but if I rotate it, you can see turning it makes absolutely no difference. So we can't adjust the separation. See, it just never moves. So we're going to need to replace that. And I have a few ideas of what I want to do. I don't really like this design, so I think we're going to try to use a different type of pot in there. Wow, where did I leave off? So it's been a while since I was on this. It's been a few days at least, and things have been really busy at work. So I'm going to try to pick up where I think I left off and fill you in. So if I repeat some things that were in a previous clip, that's why. This is where we are. We replaced that bad potentiometer. And let me see if I can find it in here. I don't even know where it went. The old one was defective. It needed replaced. And I don't know. Oh, there it is. So if you look, this is right here. And the little carbon track in it is just broken. So it essentially was doing nothing in the circuit. And where it's located is the, let's see here. In this part of the circuit, this is your separation control. And that's that pot that sits on top. And if you look at the extra module I have, you can see it up there. And I just replaced it with a normal potentiometer, and I soldered it on there. And I think I showed a picture of it. If not, we'll look at it later. But I kept these original leads as they are, and I soldered the pot right directly to the chassis, just here and here, kind of similar to how they did on this one. And it worked, okay? So we have separation adjustment now. And if I feed a stereo signal into it, this is what we're getting out right now. We're going to have to explain a few things. So you can see right and left, and you can see how this is a very distorted signal. This one's distorted as well. And right now, I am at about 75% modulation of the audio. And watch what happens as I turn the modulation down. Things start to clean up, but as you notice, the amplitudes are very different. If I turn, like I'm at 30, there's 35% modulation. You're getting a sine wave now, but you can see that there's a lot of difference in the amplitude of right and left channel. And you can see as I turn this up, the signal starts to distort. I mean, right there, we're only at 65% modulation. And if we take it up to like 90%, that's 90. It starts flat topping pretty badly there. Now, if I go to right channel only, you can see we are getting some separation now with that pot. And if I adjust the pot, you can see I can really flatten that. But if I move to the right channel, now this one's got some bleed over. And if I flatten that one out, just like that, now I go to this channel and it's off. So you can't balance it. Even though the balance pot works now, you can never get the two channels balanced. All right. And if we just go to just straight mono, or if we just go to mono on the stereo unit, so in other words, I shut the multiplex unit off here and I go just to straight FM. There's FM. Perfect signal. Even with the 90% modulation, all of the noise is gone. I have a little bit of that ringing in there, you could see, but again, the receiver is open right now. I have a bunch of things on the bench. We're picking up some noise, so ignore that. But you can see the amplitude is the same. You know, the FM section is working perfectly. It's only when we switch that module in. You have to understand how this receiver works. It's not like other receivers. There's actually a loop when you select, here we go, when you select FM stereo, since this is a standalone multiplex decoder module, it actually kind of breaks the circuit path and it inserts that module in line with that, and then the audio loops through this. So this unit, this becomes part of your audio path. And you can see right now when you switch to normal FM, it's like this module is not even in there. It just totally bypasses it. So this is like a mono FM tuner right now. But if I take this knob and I switch it to stereo mode like that, it's now looping the IF through this, okay, using the multiplex and everything. And you can see even in mono, that's mono, I'm putting a mono FM 400 hertz modulated signal in there. You can see what it's doing. So this multiplex module still has issues. All right, now why is it doing this? So what we're going to be interested in is this section right here. Back here is where you're going to detect your 19 kilohertz pilot tone, and that 19 kilohertz pilot tone is going to be filtered out or extracted, let's say, and it's going to be used, number one, to create our 38 kilohertz, to regenerate that, and it's going to also control the phase of everything, because that's really important with all this. So essentially you're going to have three adjustments. You have your 19 kilohertz, you have your 38 kilohertz, where this is your frequency doubling circuit, and then you have this 67 kilohertz SCA trap that you adjust. This isn't really important right now for what we're looking at. Once your 38 kilohertz is regenerated, it's carrying all of the audio information for your left and right channels. And through these full bridge rectifiers, we are going to split that off and we're going to generate our right and left channels here. And these are those germanium diodes that we replaced, because if you recall in one of the previous segments, several, if not all of these, were pretty bad. I mean, all germanium semiconductors have some degree of leakage in them, but these ones were exceptionally bad and were causing problems. We also replaced this pot here. But now what we're going to do is we're going to actually look at that information. If you notice, there are three 33K resistors here, and they're all kind of isolating this from here, okay, or current limiting, or whatever you want to call it, changing the impedance. And what we're going to do is we're going to read what kind of signal we have at the input of these series of resistors, or this set of resistors, and then we're going to look at the output of each resistor. And what we should see, since we're using a mono signal right now, we should see basically the same information on each point here, just out of phase with one another. All right, so we're going to look at the information here, and then we're going to look at it basically on either side of each resistor. I don't know if that makes sense. So zooming in, it's kind of hard to see it, but you have this one down here, and this one down here. Those are your four resistors. And down here at the very bottom, you see these two little tiny capacitors. Those are these capacitors here and here. Okay. And what we're going to do is we're going to look at the junction of these coupling capacitors and these 4 resistors. So we're going to look here and here first. Okay. Let's get you up on the scope. And if I look at the one side, these are all with respect to chassis. Okay, and you can see we have a nice sine wave. Ignore this noise. This will be filtered out. All that noise that you're seeing is going to be filtered when it goes through this little network here before it goes out to the audio. We're actually looking at it before all of that. And that filter may have problems too. We're going to have to check that later. But for right now, that's one side. There's the other. Okay, one and the other. They're pretty symmetrical, I would say. All right, now we're going to look at the other end of each of those resistors. So now we're going to look here, 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 and here. Again, they should all be the same, just with different phase, okay? So here's the first one. Not very good, is it? Here's the other one. And then here's the other channel, those 2 resistors. There's one. There's the other. So you can see they all are asymmetrical. They're not correct. So if I clip on this channel, I actually have to increase this in amplitude on the scope just to even get it to lock. See, that doesn't look anything like it should. And if I look at this one, all kinds of amplitude, but it's still very distorted. Then I look at this channel. That's not too bad. And then this channel, and it clips. And again, you should see the clipping because you're looking at each half of the waveform. So what I'm saying is one side is not bad. Okay, this one is actually working, but there is a little bit of amplitude difference. But the other channel, I don't know, we'll call it right channel and left channel, is not. It's really bad. That one's halfway decent. This one's really bad. Okay, now there could be other components theoretically that could affect this a little bit, but it should affect it the same way on each channel. All right. So if I go resistor number 1, remember these are all 33K. That one's a little low, it's 27.4K. If I go to the other one, it's 31.2K, so that's a little closer to 33K. But you can see they're quite a bit different. Now if I go to the other side, and I clip on here, and I check this resistor, it's 34.5, so it's a little bit high. And if I look at the other side, it's 24.6. So almost, 10K difference. So these resistors are bad. They're probably really out of tolerance. I mean, they should read 33K, and they're not. So either the resistors themselves are bad, or some associated component that's in the circuit is bad. Okay, bad lighting, but hey, we're going to live with it. So if I'm reading with my ohm meter from here to here, there's really not a whole lot that you're reading through without these, these diodes. I mean, everything is very high resistance compared to this 33K. So essentially these should be pretty close to 33K, and as you saw, they are not. They're very different. So at the very least right now, these also will need to be replaced. Whenever I don't understand something, you know me, I redraw it. So what I did was I just went into Paint and I just cropped out the part of the circuit we're interested in. And I put the original one we have in the schematic versus what we have in reality when we look at the circuit that we have. And it's pretty interesting because in this circuit you have these two resistors, these 1 meg resistors on each bridge that are kind of shunting across the output like this. And you don't have it in our multiplex unit. The other thing is this charge capacitor here, this 1 microfarad. It has a 1 mega ohm resistor referencing it to ground, but in ours it's not there. You just have these two 100K resistors with the cap going into it and nothing referencing it to ground. And I can see this is factory. Nobody has modified this. And if I go in really close, I'll try to get as tight as I can with the camera without it kind of getting wonky on us, but that's pretty close. So there's our 1 microfarad capacitor. And here is one of the 100K resistors that goes to it. That's this back terminal is where this connects to. And then underneath the little board here is the other 100K. So here's the output of the one bridge for the one channel. Here's the output of the other bridge for the other channel. And underneath here, my pointer is touching it right now, is the other 100K resistor. You can't see it, but it's right down here. The tip of the pointer is touching it now. So those are the two 100Ks. And they both converge right here on this back terminal. And there is no 1 meg resistor going from that terminal to ground. And just to verify that, if I read from that point, and I'll back you way out now. If I read from ground, which right here, this is on chassis ground, and I read to that point back there, I'm reading 98K. Now I don't know if we reverse the leads, if we're reading something across a diode or something. Again, these germanium diodes are kind of, nope, it's 100K in either direction. So with respect to ground, we are reading 100K from here to ground. And really we shouldn't when you think about it, because you have a capacitor here and you have two resistors here, and there is no, going to the big picture, there is no reference to ground here. Okay, you got a cap here, you got a cap here, so there should be no reading of anything with respect to ground from here. It should be almost like an open circuit, because unless you're reading back through these diodes, which you shouldn't technically be able to read all the way through all these diodes to ground. And by the way, I did check the diodes. All of them are good. There are no, I mean, they have normal leakage that you would see on a germanium diode, but not 100K or whatever. So there's something weird going on. Maybe my capacitor is bad. We're going to have to check that. Okay, now this is where we are. And there's been quite a lot since the last clip. I decided to pull the module to make it easier to get to everything and to check everything. I replaced the 4 resistors, and you can see them in there. And you can see the addition of some other components. First of all, I removed that electrolytic because it just didn't fit in there right. And I found this film capacitor that should be just as good, if not better, and it was an axial lead, which was a lot easier to fit in there. So I replaced that. Those 5 extra resistors, if you recall. So in the original module as we found it, all of these 2 resistors, these 2 here, and this one here, were all not in there. So it kind of looked like this. So no 1 meg to ground and no bypass right here. What those are mods that were made later on, probably in a later production run, that were put in there in order to reduce distortion. And I think that's part of why we are getting some problems with, like especially when you're over modulating and so forth. It should help with that a little bit. So I added those 1 meg resistors, and you can see they go across these 4 diodes here, and then that other one, you can't really see it, well maybe you can't, is right there, and that goes from this lead to ground. Now strangely enough, when we look at our newer module, the updated one that I have, mine's a lot newer. First thing you notice is you see how neat the 2 bridges are. And you can see there are 4 1 meg resistors. So here's your 2 1 megs, and they go to here, and then this goes over to there. So that's that one. And then these 2 go here, goes to here. So you can see how much neater it is, instead of them kind of flying leads, you know, the way that the old module is. And then that 1 meg resistor to ground, it's actually down inside here. It's very hard to see, but it's located right down there. See it? And it's going to that ground lug right there, and it comes from over here. So this is what the newer module looks like with the modifications. Much neater. You can tell this was like an early production, and it had some issues with the layout. This one is much neater how it's laid out. And again, I could plug this one right in there and use it, but I chose not to. The schematic, for instance, shows these 2 capacitors as 3900 picofarads, and you can see in this one they have 5100. I'm going to leave those for now. And you can see a couple places where they used ceramic in the original, and they went to a mylar or a film capacitor in the later ones, here and here. So there have been changes that have been updated, and we could continue doing all this, but I'm going to just do this much that we did. The other thing is, you have to remember, they changed some of those other values because the later ones, like this one, they used all 12AX7s, and this one uses 2 12AT7s and a 12AX7. So that's also, it's going to change a few of the values of the resistors and so forth for the biasing, and that's not, I don't have a schematic of that. So that's going to be another difference, and of course we're not going to, that's why we're not going to modify it beyond those resistors, those 1 meg resistors that I added. So let's get this module back in and see if we fixed it. Oh, most important thing of all, another problem I found was this diode right here. You see it? This one back here, it was in backwards. I had to reverse it. So when I checked my work the first time, I missed that. And I think that was causing the strange clipping problem on the one channel. So it'll be pretty exciting to see now if they match. And with these mods, if it'll be a little bit cleaner and won't clip as much. Okay, everything's back in. And I'm going to first probe here and here, the 2 outputs of the 38 kilohertz circuit. So essentially we're going to look here and here in the circuit just before the diodes. So let's get you up to the camera, or I mean to the oscilloscope. Okay, now here's the first one, side one, and look at that. All the noise is gone and it looks really clean. And let's go to side two, same thing. All right, now let's look at our bridge rectifiers, our bridge circuits. So now we're going to look at here, and we're going to look here and here. And what we should see is we should see half of the waveform. Okay, so here's the first side of the first channel. That looks good. There's the other side of the first channel, and you can see it's the opposite. Then we have the other channel, first side, and the other side. Okay, I think we got it fixed. So now let's switch over and look at the output of our record out jack. So this would be like what the amplifier and what the speakers would be hearing. Okay, this actually looks really good. So here's your stereo right and left channels as the record output jacks look. And if I go to left plus right, that's your mono. Left minus right, it should invert, and it does. Right only, and you can see right there we have pretty good separation. And left only, and I got to change the trigger right there. And we can probably even flatten that out a little bit more by adjusting the separation control. So let's see what we can do. Right there is about as good as we can get it there. And not too bad there. Now all this noise here, I think we're still having problems with our filter. We're going to have to fix that. But we have stereo sound now. And the stereo beacon is working as well. Okay, the radio is sitting on its side, so this isn't the greatest view, but I have this set to mono right now. Now watch what happens when I turn it on to stereo. See what happens? So this, when you're in stereo mode, they repurpose this tuning indicator to be a stereo beacon. So when the eye is closed, that means it's a stereo signal. And when it's open, it's a mono signal. And you can kind of see on the scope how it changes a little bit. Yeah, let me turn the light back on. So if we go from stereo to mono, you can see what it's doing right there. And again, this is the module doing this. If we switch into straight FM, it bypasses that module, and you see how nice it looks. And it doesn't really care. There's your stereo signal again. It's picking up that pilot. So there's still some problems in the tuner that we're going to have to get to filter out all the frequencies above the 15 kilohertz. That's the bandwidth of FM. But we're very close to having this totally fixed now. All right, let's take a quick look and see why this is why it is. Up here is your ratio detector, and the output of that is right here. This is where your detected audio comes out. So in normal FM mode, all you're going to see is your FM signal passing through here, this little filter here. It passes right through this multiplex output jack, through this little coupling capacitor, 0.05 microfarads. And then this goes down to your switching network to be switched into your amplifier and your tone control section and everything. So this is your actual audio right here. And if you notice, there's a little capacitor here that doesn't look like it's very important, but it actually is. This is a 0.0018 or 1.8 nanofarad capacitor. And what this 1.8 nanofarad capacitor does is it's a high pass filter, it's a low pass filter, low pass filter. And what it does is it's supposed to attenuate that 19 kilohertz pilot tone from the multiplex. But of course, this is about the simplest filter you could have. So there's a trade-off. This will only roll off at something like 6 dB per octave, or maybe even worse than that. And what that's going to cause is that it's not just going to clamp off the 19 kilohertz. It's going to start clamping it off before 19 kilohertz a little bit, and at 19 it'll be rolled off a certain amount. And then as you go higher than 19 kilohertz, it'll attenuate the signal more and more. The problem is, if we increase this to the point that it totally squelches out that 19 kilohertz pilot tone, it will also attenuate the high frequencies of your audio. So they had to use a capacitance that was a trade-off between those two. Remember, this is designed to perform up to 15 kilohertz. That's what FM audio is. And so, of course, it's not the full fidelity that you would hear 20 to 20 kilohertz. Now, normally in more modern circuits and more complicated circuits, they would have an actual, either a notch filter in here to notch out that 19 kilohertz, or they would have a really sharp filter that would very sharply at 19 kilohertz cut everything above that out. But that requires more circuitry, and they just weren't going to do that in this. It's not really important because your ears can't, it's so far rolled off with this capacitor that your ear isn't going to hear that. So if we go back up to our oscilloscope waveform and we look, and I'm going to try to make this so you can see it a little easier. So you're looking at a 5 kilohertz stereo signal. Okay. So we have the stereo module switched out of the circuit right now. So I have a stereo signal that we're tuned into, but we're not using the multiplex module. So you can see just the tuner by itself is not getting rid of that 19 kilohertz pilot. When we switch in the multiplex circuit, which is right here, you can see that a lot more noise comes in through that circuit. And of course, some of this has to do with everything being open and everything, but you can see there's noise there. And if we switch through left plus right, left minus right, right only, and left only, you can see the right channel has a lot of noise in it, but you are getting the stereo separation. But here's where it gets kind of strange. If I go to right only, so you can see the left channel is pretty much out. Okay, there's pretty good separation. But if I go to a 1 kilohertz tone, it's not too bad yet. If I go to a 5 kilohertz tone, you can see it starts to bleed over even more. And this is the old technology here. And if I go to the left only, same thing. And again, I'm not syncing very well on anything, and I'm using chop mode instead of... We'll have to go over what chop and alt means one of these days. But anyway, you can see that that's some of the limitations of this really, really basic looking circuit. And of course, so there you go. That's just what you're going to have. That is old stereo for you. Now, we modified a few things to make it better, but it's still not perfect. But you would get the effect of stereo if you were to listen to this and tune in a station. And we'll do that, but this should give you an idea. Now I still have to figure out what this ringing is on this channel. I'm not sure what it is. Okay, we finally got it. And I'll show you what all it was. There was a couple things. Number one, right in between the filament pin and pin 3, there was a lead that was just kind of sticking out of the end. It was when they made it in the factory, they didn't crop it off far enough down, and it was almost touching that filament pin. And that was causing that oscillation in the one channel. Additionally, we don't have quite enough drive signal. The original capacitors that were in there were these ceramic 0.02 microfarad. You can see them right there. And those were right here in this position. And if you notice in the schematic, this is an updated schematic. They're 0.047. In addition, later models changed this from a 22K to a 27K. So this all has to do with the filtering network and everything. Now this makes it very touchy to adjust, but once you get it, you get really good stereo separation. And let's get you up here on the monitor, or on the oscilloscope, I'm sorry. And if you look, that's a stereo signal right now. Here's mono, and you can see there's nothing in there. Stereo, and you see your little pilot tone, and that's, as I said before, that's just the way this thing's going to work. You're not going to get rid of that tiny little bit, but you can't hear that. Here's left plus right, left minus right, and you can see how sometimes it gets a little bit flaky. And then there's right and left, and you can see we're going to have to touch this up a little bit yet. And I'm still trying to figure out this. See, it's just right on the edge. If you go too much, and the problem is this control is very touchy, and you can't really turn it precision enough. So right there, see, that's not right. It needs to be, it's still a little bit off peak, but you can see there's your right and your left. And you can actually get it really flat if you want with the adjustment. So we're still going to need to work on it a little bit. But I'll have to fine tune it with just, see, if you just touch it with the tool, but I can't move it. If I move it, it jumps because that slug in there is kind of sticky. Right, see right there, it jumped. I can't move it close enough, but let me fiddle with it, and we'll show you the finished product. Okay, another mod that had to be done. So we have this 5100 picofarad silver mica capacitor. And you can see we replaced it with a 3900. And if you look at the schematic, that's what it has in this later version. What that does is that makes this coil a little less sensitive to adjust. It gives it less range, is what I should say, to adjust it, but it also gives you more precise adjustment. So I think that's why they changed that, because it made it easier to tweak in. Now that we have it, let's take a look up here. There's left plus right, left minus right, right, and left. And you can see right there's left. And we can adjust the, kind of get it flattened. And you really have to mess with it to get it. And it's still not quite perfect. It still needs a little bit of tweaking. But this is what this stuff is. It's totally analog. There's no phase lock loop, anything like that. So any component that changes value, if a capacitor or a resistor gets heated up or something and changes its value, it's going to throw this whole thing off. So this is what you deal with when you're working with this old technology like this. But it is working. Okay, one last check. There's right, left, left minus right, left plus right, and stereo. I think it's time to listen to it. Well, anyway, you can't really hear anything over a mono lapel microphone, but I will tell you it's working and it sounds pretty good. There is some static if we, of course, my setup here, if I stop the music and just play it with a carrier, you can hear some static in the background. Part of that is the old circuitry in the tuner and so forth. Some of it is my setup on my bench. But I am getting pretty good stereo separation. It's not perfect, and it never will be, because this is a really early generation multiplex unit. But I think it's as good as it's going to get right now. And it sounds nice, and it's pretty surprising how good it does sound. One last thing is I replaced these burned out bulbs in the faceplate with these. I was able to order online, and if you notice, these are not normal 6 by 32 or whatever they are fuse type light bulbs. They're actually 5 millimeter, I think 5 or 5.5 by 60 or 40 or something, 52, I forget. Well, we could measure them. They are, yeah, they're 42 millimeter by, let's see, 4 millimeter. So they're 4 by 42 millimeter. So they're an odd shape, but I found these on eBay, a company that was making them. So I gave it a shot, and they work. They look really good. They look very natural. They don't flicker. They almost look as good as the incandescents that were in there originally. So, well, let's give it one last listen with, on the auxiliary input. The tuner is working now. And just so you know, we're tuned into the carrier right now with no signal. And if I shut the signal generator off, we'll kind of move you up here and show you. And if I shut this off, so pretty quiet, not bad. And if I turn it back on, let it fire up, pretty nice. And that's with a stereo signal tuned in, so not bad. All right, let's try one last song, and then we're going to wrap this up. Okay, let's try Mirage by the YouTube library. I like this one. It doesn't have a whole lot of dynamic range, but it does have, it's a nice clean sounding song, and it's very good with the high frequencies and so forth. So let's get the recorder going, and then let's start it up, and then I'll get out of your way. Not bad. Not bad at all. Well, that ends this series. Everything works. We did the phono stage, we did the amplifier, the preamp, the tone section. We repaired the multiplex module and cleaned it up a little bit, replaced all the capacitors, and did proper alignment on it, or at least verified the alignment. And that's it. So I'm going to wrap this one up. I have another project I want to do before I start any more repairs or restorations. And we'll see if I get to share that or not online or not. I don't know if I'm just going to get the job done or if I'll record it, but we'll see. But anyway, I wish you all peace, joy, happiness, and good health in your lives. And I look forward to the next project to get posted, and I look forward to all your comments. And there goes the computer. And, well, we'll see you again real soon. This is going to be an epic video, I can tell you right now, this last part, because there's so much that I did. So we'll see how it turns out. How about it? All right, until then, take care. Bye-bye.